The laws of indices. Learning intention. Simplify expressions using the laws of indices, including fractional and negative powers. Success criteria. I can. Apply index laws, add, subtract, multiply, divide powers. Use fractional powers as roots and powers. So a to the power of m over n is equal to n root a to the power of m. Use negative powers as reciprocals. So a to the power of minus n is equal to 1 over a to the power of positive n. Rewrite expressions as whole numbers or fractions. Express answers in required forms. Example, a over b, a power of a base. This is page 21 of your formula book. Indices and logarithms. For Leaving Cert ordinary level maths, you will only need the left-hand side. So ignore all the logs. That's just for Leaving Cert higher level maths. The laws of indices. 2 to the power 3, or 2 cubed, is equal to 2 by 2 by 2, which is equal to 8. So 2 with a little 3 on top is called 2 cubed, or 2 to the power of 3. 3 is the power or index, which tells us how many times the number 2 is multiplied by itself. Multiplication. 4 to the power 2 times 4 to the power 3 is going to be 4 by 4 by 4 by 4 by 4, which gives us 4 to the power of 5. So to multiply powers of the same number or the same base, we add the indices, we add the powers. So 4 to the power of 2 times 4 to the power of 3 is 4 to the power of 2 plus 3, which is 4 to the power of 5. Similarly, x squared times x cubed is x times x times x times x times x, which is x to the power of 5. So x squared times x cubed is equal to x to the power of 2 plus 3, which is x to the power of 5. So focusing on multiplication. So this is our first rule. So this is what you'll see in your formula book. A to the power p stuck on a to the power q. The two things stuck together in maths mean multiply. So this really means a to the power p multiplied by a to the power q. And the rule is a to the power p plus q. So multiplying powers with the same base, we add the powers. So that's the very first rule in the formula book. So for example, if we have x squared times x cubed, we're going to get x to the power 2 plus 3, which is x to the power 5. So multiplying powers with the same base, we add the powers. Likewise, if we have y times y squared, well, y on its own is really y to the power of 1. So we're going to get y to the power of 1 plus 2, which is y cubed, or y to the power of 3. So multiplying powers with the same base, we add the powers. Let's say we have 5 squared times 5 times 4. Well, that 5 on its own there is really 5 to the power of 1. So it's going to become 5 to the power of 2 plus 1 plus 4, which is 5 to the power of 7. So multiplying powers with the same base, we add the powers. So that's the very first rule. The laws of indices. Division. 3 to the power of 5 divided by 3 to the power of 2 can be rewritten as 3 by 3 by 3 by 3 by 3 divided by 3 by 3. And the first 3 on the top cancels with the first 3 on the bottom. The second 3 on the top cancels with the second 3 on the bottom. And we're left with 3 3s. So we're left with 3 to the power of 3. So to divide powers with the same number or the same base, we subtract the indices. So 3 to the power of 5 divided by 3 to the power of 2 is really 3 to the power of 5 minus 2, which is 3 to the power of 3. Similarly, if we were to do x to the power of 5 divided by x to the power of 2, it would be x by x by x by x by x divided by x by x. The first x on top would cancel with the first x on the bottom. The second x on the top would cancel with the second x on the bottom, leaving us with 3 x's multiplied together, which is x cubed. So x to the power of 5 divided by x to the power of 2 is x to the power of 5 minus 2, which is x to the power of 3. So dividing powers with the same base, we subtract the powers. Or dividing powers with the same number, we subtract the indices. So this is the second rule in your formula book. So this is the rule for division. So to divide powers of the same number, we subtract the indices. So this rule is a to the power of p divided by a to the power of q is a to the power of p minus q. So if we have x to the power of 5 divided by x to the power of 3, dividing powers with the same base, we subtract the powers. So you get x to the power of 5 minus 3, which is x squared. So dividing powers with the same base, we subtract the powers. Let's say we have y to the power of 4 divided by y. Well, that y in its own is really y to the power of 1. So we're dividing powers with the same base, so we subtract the powers. So y to the power of 4 minus 1 gives us y to the power of 3, or y cubed. So dividing powers with the same base, we subtract the powers. Let's say we have 3 to the power of 2 divided by 3 to the power of 5. Dividing powers with the same base, we subtract the powers. So we have 3 to the power of 2 minus 5, which is 3 to the power of minus 3. The laws of indices, rule 3, a power to a power. So to raise a power to a further power, we multiply the indices. Or to raise a power to a higher power, we multiply the indices, we multiply the powers. So x squared raised to the power of 3 means x squared by x squared by x squared, so 3 times. And x squared by x squared by x squared, here we're multiplying powers with the same base, so we add the powers. So 2 plus 2 plus 2 is 6, so we get x to the power of 6. But a quicker way to do it is to just multiply the powers. So x squared raised to the power of 3 is going to be x squared times 3, which is 6. So similarly, x to the power of 4 raised to the power of 3 is going to be x to the power of 4 multiplied by 3, which is 12. So raising a power to a higher power, we multiply the powers. Or raising a power to a further power, we multiply the powers, or we multiply the indices. And a product raised to a power, so if we have ab to the power of n, that's the same thing as a to the power of n multiplied by b to the power of n. So we'll have a look at this one later on. So the third rule, a to the power of p raised to the power of q is equal to a to the power of pq. So a to the power of p raised to the power of q is equal to a to the power of pq. And here the p and the q are stuck together, and two things stuck together in maths means multiply. So this really means a to the power of p multiplied by q. So raising a power to a higher power, we multiply the powers. So x squared raised to the power of 5, raising a power to a higher power, we multiply the powers. So we get x to the power of 2 multiplied by 5, and 2 times 5 is 10. So raising a power to a higher power, we multiply the powers. Y to the power of 3 raised to the power of 4, raising a power to a higher power, we multiply the powers. So it's y to the power of 3 multiplied by 4, which is y to the power of 12. So raising a power to a higher power, we multiply the power. Or raising a power to a further power, we multiply the power. So let's say we have 6 to the power of 2 raised to the power of 2. We have 6 to the power of 2 times 2, which is 6 to the power of 4. Laws of indices number 5. Any number to the power of 0 is 1. So a to the power of 0 is 1, 10 to the power of 0 is 1, and so on. So there's that law there, a to the power of 0 equals 1. So for example, x to the power of 0 is 1, y to the power of 0 is 1, 10 to the power of 0 is 1, and let's say we have x cubed divided by x cubed. Well, here we're going back to our second law, which is dividing powers with the same base, we subtract the powers. So we get x to the power of 3 minus 3, which is x to the power of 0, and x to the power of 0 is 1, because anything to the power of 0 is 1. And this makes sense because x to the power of 3 divided by x to the power of 3, dividing anything by itself gives us 1. The laws of indices, 6 negative indices. 4 to the power of 3 divided by 4 to the power of 5 can be written as 4 by 4 by 4, multiplied by 4 by 4 by 4 by 4 by 4. The first 4 on the top and the bottom will cancel, the second 4 on the top and bottom will cancel, and the third 4 on the top and bottom will cancel, leaving us with 1 on the top and 4 by 4, which is 4 squared on the bottom. Also, 4 to the power of 3 divided by 4 to the power of 5 gives us 4 to the power of 3 minus 5. Dividing powers with the same base, we subtract the powers, which is 4 to the power of minus 2, which also gives us 1 over 4 to the power of positive 2. So this is our rule here. So a to the power of minus n is equal to 1 over a to the power of n, or a to the power of minus 2 is equal to 1 over a to the power of positive 2. So this is our negative indices rule. So a to the power of minus p is equal to 1 over a to the power of positive p. So I just wrote it out there again in bigger writing. So this is in your formula book. So let's say we have x to the power of minus 2 this is going to become 1 over x to the power of positive 2. Let's say we have y to the power of minus 3. This will become 1 over y to the power of positive 3. Let's say we have 2 to the power of minus 4. That will become 1 over 2 to the power of positive 4. And then on the bottom here, the denominator, 2 to the power of 4, we can rewrite as 2 by 2 by 2 by 2. So we actually end up getting 1 over 16. So 2 to the power of minus 4 is also equal to 1 over 16. The laws of indices, fractional indices. We use the rules of indices to show that 2 to the power of half is equal to the square root of 2. So if we have 2 to the power of half multiplied by 2 to the power of a half, multiplying powers with the same base, we add the powers. So we get 2 to the power of a half plus a half, and a half plus a half is 1. So 2 to the power of 1 is also 2. And we know that root 2 multiplied by root 2 also gives us 2. Therefore, 2 to the power of a half must be equal to root 2. Similarly, 2 to the power of a third is going to be equal to the cube root of 2. So over here in our yellow box, 2 to the power of a half is equal to the square root of 2. 2 to the power of a third is equal to the cube root of 2. So the rule is 2 to the power of 1 over n is equal to the nth root of 2. So here's our formula book again. And this is the rule. So a to the power of 1 over q is equal to the cube root of a. So a to the power of 1 over q is equal to the cube root of a. So this is given in the formula book. So if you have x to the power of a half, then the denominator, which is 2, is going to go in front of a root. So it's going to be 2 root x, and 2 root x is the same thing as the square root of x. So x to the power of a half is equal to the square root of x. So anything to the power of a half is equal to the square root of that term, or that number. Y to the power of a third is equal to the cube root of y. 32 to the power of a fifth is equal to the fifth root of 32, which is equal to 2, because 2 to the power of 5 gives us 32. And 27 to the power of a third is equal to the cube root of 27, which is equal to 3, because 3 cubed is equal to 27. The laws of indices, more fractional indices. One of the rules of indices is a to the power of m raised to the power of n is equal to a to the power of m stuck on to n. And m and n stuck together mean m multiplied by m. So this really means a to the power of m raised to the power of n is equal to a to the power of m multiplied by n. So this is our third rule that we looked at earlier on. Raising a power to a higher power, we multiply the powers. From this rule, it follows that 27 to the power of 2 over 3, or 2/3, can be broken down as 27 to the power of a third raised to the power of a 2. Because if we work backwards, a third multiplied by 2 is 2 over 3. And then 27 to the power of a third, we can rewrite as the cube root of 27, and the squared is still there. And the cube root of 27 is 3, and 3 squared is 9. So 27 to the power of 2 over 3 gives us 9. So just note that if you have brackets and then the cube root of 27 and brackets and the squared on the outside, it's the same thing as having the cube root of 27 and then the squared attached to the 27. It's the same thing. So let's have a look at this a bit closer. So 8 to the power of 2 over 3 is equal to the cube root of 8 raised to the power of 2. So the denominator, the 3, goes in front of the root, and the numerator, the 2, becomes the new power. Likewise, 16 to the power of 3 over 4 is equal to the fourth root of 16 raised to the power of 3. So the denominator 4 goes in front of the root, and the 3, the power, becomes the numerator becomes the new power. And we can summarize that as x to the power of m over n is equal to the nth root of x raised to the power of m. So the denominator, whatever it is, that goes in front of the root, and the numerator, whatever that is, that becomes the new power. So let's have a look at this rule again in more detail. So in the formula book, it's a to the power of p over q equals the cube root of a to the power of p, which is equal to bracket the cube root of a bracket raised to the power of p. So this is probably the hardest of all the rules. So a to the power of p over q is equal to the cube root of a to the power of p, which is equal to bracket the cube root of a bracket raised to the power of p. So I've just wrote out the rule bigger. This is what you will see in the formula book. So focusing on the numerator, p, whatever that may be. So notice now that the p becomes the new power on top of the a, or you can write it outside of the bracket. And then the q, which was the denominator, goes in front of the root. And here it's after the bracket and in front of the root. So remember, these two things mean the same thing. So let's take x to the power of 2 over 3. So the numerator is 2. So if we focus in on the yellow peas, so the 2 is going to be the new power. And the denominator is 3. So the 3 is going to be in front of the root. So x to the power of 2 over 3 gives us the cube root of x squared. So x to the power of 2 over 3 gives us the cube root of x squared. Y to the power of 4 over 5. So the numerator is 4, so that's going to be the new power. And the denominator is 5, that's going to go in front of the root. So we get the fifth root of y raised to the power of 4. So the numerator 4 is the new power, and the denominator 5 goes in front of the root. So the fifth root of y to the power of 4. Let's say we have b to the power of 3 over 2. That gives us the square root of b cubed. So the 3 is the numerator, and that's the new power. And the 2 is the denominator, and that goes in front of the root. And the square root of b cubed is also written like this. So you can have the 2 or not. It means the same thing. The next rule. ab raised to the power of p is equal to a to the power of p multiplied by b to the power of p. Now, two things stuck together in maths means multiply. So we know that this really means a to the power of p multiplied by b to the power of p. Now be careful here because we are not multiplying powers with the same base. A and b are not the same. So it is not this first rule. So just be very careful there. So let's say we want to break down 20 to the power of 3 into its factors. So we can rewrite that as 4 to the power of 3 multiplied by 5 to the power of 3 because 4 times 5 is 20. Or we could rewrite it as 2 to the power of 3 times 10 to the power of 3 because 2 times 10 is also 20. Or we could rewrite it as 1 to the power of 3 times 20 to the power of 3 because 1 times 20 is 20, and so on. And then the last rule is a over b to the power of p is equal to a to the power of p divided by b to the power of p. So a over b to the power of p is equal to a to the power of p times b to the power of p. So let's say we have 2 over 5 to the power of 3. Well, we can stick the power onto the numerator and the denominator. So we get 2 to the power of 3 over 5 to the power of 3. Let's say we have 1 over 6 to the power of 4. We can rewrite that as 1 to the power of 4 over 6 to the power of 4. So we attach the power to the numerator and the denominator. And let's say we have 5 over 4 to the power of 2. We can rewrite that as 5 to the power of 2 over 4 to the power of 2, and so on.